All right. So milestone 2. Hopefully by now you have started your code. I think it's been fairly quiet on questions. Most of the questions have been maybe around milestone 1, the grading, getting feedback on more details on that. I haven't had a lot of questions on specific code. I did work with a few teams last time and get started on that with some of the code, but we have theoretically 30 teams out heavily working on that, and I have only a small representation. So the plan here is you're going to produce your VNaughts, and then from that be able to get that curve to be able to calculate your Vmax and your case of M. And so the videos have kind of sort of put you along that way. And I've made the conscious choice that I wanted to let you work through some of the decision making inside of that, and some of the choices in design, and the hit things that maybe you were struggling on, or that you work through it on your own. I think that at some point you need to be able to start to understand the uncertainty that is engineering. That there's many ways to be able to solve this. There's many ways to go about this. That being said, you do have an assignment that's due in a few days, so I wanted to use today as a chance to really talk about these curves and what they mean. So, from your M1, you made some choices, and you were asked to come up with 2 ways of being able to solve these different variables. The first one being V0. How do you figure out what this initial curve is, this initial slope of this of the time versus the concentration changes, or at the concentration? How do you figure out each one of those? And a lot of you took some interesting solutions out there. I'm not sure if you were able to code them yet. Hopefully you have. But that's the first choice, is how do I figure this? Do I look at point 0 and point 1? Do I look at some rolling average? What are the different choices that you have inside of there? And I want to talk a little bit about that choice. And then the second choice is, how do I figure out this max, and how do I figure out this intersection point in between? So I, last week, I think either Wednesday or Thursday, I built this project. I wrote, at least through M2, I went through and wrote the code that I thought would be a good way to do it. And if you haven't started yet, I'll tell you, it's not trivial. It took me at least an hour to come up with the code that I wanted to have. Probably about an hour and a half I spent working on it. And the 2 things I'll tell you is, number 1, I hope you believe by now, I'm probably a faster coder than you are. There's things that I do in an hour that takes professional people a couple hours to do. So it might you might work 5 or 6 hours in this code. You might also do an hour. You might be a great coder. I'm not trying to say you shouldn't have done that. But the other thing I'll say is, I did not focus on 2 or 3 options. I didn't worry about the quality of options, because, again, I don't want to take away your experience and your measurements and stuff like that. I just want to create a base framework of code. If you haven't started anything, you don't know where to start, at least I can show you something. We're going to talk about that here in a little bit. But don't think that what I'm showing you is even a good answer, much less the best answer. It's a good answer to get started in code. It's not the algorithms that you need to be to solve this solve this problem for your fictional company. So I also want to point out, this is a good reminder inside of here, your algorithm that you're putting in, should be taking advantage of user-defined functions. I didn't do that in my first cut of this code. Couple reasons I didn't do that. Number 1, I was just spitting out in a hurry. I wanted to see what it looked like. Number 2, I hadn't decided what my design of everything was going to look like. I haven't gone through and planned out the whole response yet. Number 3, it's okay to do that. If you aren't at a point where you think in terms of functions and user-defined functions, that's not a terrible thing. But I want to show you the rough cut I took today because I did want it to be rough cut. I also want to compare that to another application that I've been playing with on the side. I'll explain it when we get to it. But how much easier it is to make reusable functions even for something like this that will speed up your development and improve your solution. So is there any questions I can answer before I jump into and share my MATLAB, what I have going on? So if you have questions, you can type them into chat, you can raise your hand, you can just jump in and speak. If you don't have questions, maybe do the whole no/thumbs down thing, so that way I can move along quickly if the vast majority of people are not asking questions. I see one no. Three no's. The extra points were supposed to be kind of divvied up across the rest of the assignments that are coming up here. I honestly, I didn't do that math myself either. I was told that they were updated. We can go through and double check that and take that offline. I mean, the grade eventually inevitably comes down to a percentage of things, but I think they like the 1,000 point as a nice round number. So from what I understand, that they've distributed off of those. All right, so if there's additional questions, let them keep coming in. I think I'll go ahead in the interest of time, look through this, because that might answer some questions or cause more questions to come up. Yeah, I don't know that they updated the syllabus. I think what I understood is they updated the assignment sheet where the everything is. I haven't seen an updated syllabus at this point. They did update the syllabus after spring break, but I don't think I've seen another one updated after that. I can double check where that went to. It's my own foibles is I don't necessarily worry about exactly and I'm not being graded here, so I understand that you're more worried about it. But I don't worry about exactly where the points are coming from, because they're just tasks to get done. You do the best you can on each one of them, and I'm not in the mindset of negotiating. Like if I only get an 80 here, I do fine. And sort of, my wife actually used to do that in her classes. She'd be like, I don't feel like doing this. If I don't do this, and they actually had a tool, it would tell them what their grade was. Or if they did do this, it would tell them that their grade was, and she would kind of negotiate that. That's not the way I'm built, so I apologize. I didn't spend a lot of time looking at that because I was messing with some of this stuff instead. Hold on one second. Let me open up. Oops. Make sure I'm in the right MATLAB folder. There you go. All right. So let me actually step back a tiny bit. Let me go to the data. There you go. And I opened up on my other screen. So when you look at this data, there's a lot of repeating columns. And it's having a fun time opening this data. Oh, there it goes. All right, so we know that there's actually 100 columns inside of here. And so we start with the time, and then each test has, there's actually 101 columns actually. So each test has 10 different concentrations it's running from, and then it duplicates it. And then that pattern continues on and on and on. So the first question, and possibly one of the more challenging questions to get started with, is how do I read this data? So everything you've read so far kind of comes in with there's 3 or 4 things, and it's just really easy to hard code that and run from there. You might have already wrote code that hard coded all this. So you said column 1 was time, column 2 was 3.75 for test 1, column 3 was 7.5 for test 1, and so on and so forth. You might have had typed in 1 through 101 inside of there. That's not wrong. It's limited from the standpoint of it will only work for this file ever. If you got a new set of data, it has to match this one entirely precisely. And so that's one thing to consider, is how could you automate this? The code I wrote, I actually also, excuse me, wanted to show you a little bit of some advanced software development practices. I'm using not just the matrix as a way of storing this data and vectors to store this data. I'm actually using cells, and I'll explain what that means here in a second. But this code, this data has a pattern, and so the pattern that I created inside of here is, and this is where I wanted to bring up Paint, so I can take some notes here. So here's my paint. So the pattern that I saw inside of here is we start off with, we have an individual trial, is what I called it in my code, I think. So the individual trial is 1 to whatever time that trial ended. For that concentration, what is this, what is the individual measurements that happen? And so that trial here essentially is a vector of numbers, right? And so then I have a set of tests that came, a set of tests that came along that there's one for each concentration, one trial. Concentration, right? So I know that for each test, there's going to always be some number of trials, and in this case, we know it's 10. And it's hard to write with my mouse there. This should be a number 10 right there. You know what? I don't like any of those. Do this over again. My mouse is on game sensitivity, not drawing sensitivity. So, nope, I don't like that. So we have an arrow here, very badly, and then there is 10 of these. All right. So then for this set of tests, there are some number of these repeated tests that happen for each enzyme. And so there's another level on top of that. I don't remember actually what I called it. I'm just going to call it repeated tests for now. I don't remember what I called it in my code now. Just there's some number each enzyme. And so we know that we have some number of these, and that number is 2 for now. Okay, and then finally we have some number of enzymes. I think I actually call them products instead of enzymes here, because that's the idea, is there's some number of different products that you're going to be discussing, and so you have some. And so that's my pattern inside of here. So we have 5 products times 2 tests per product. So there's 10 tests that's going on here, times 10 trials per, the different concentrations. So that gives us that 100 right inside of there, plus the time, so that gives us 101 columns. So if I can figure out how to do one set of these for one product, how do I read 2 tests? How do I read the different concentrations? How do I read each trial? Then I can just continue to do that H number of times. And so this hopefully looks to you like a loop. So I have some sort of outer loop that's doing it 5 times, and then inside that I'm doing it 2 times, inside that I'm doing 10 times to be able to grab my vector of numbers. So that's the perspective of how I'm coming to this problem solving, is I can see this pattern that's going inside of here, and the best way I know of solving a pattern is a loop. At any point inside of here, I could decide to represent some part of this as some sort of big matrix. I could attempt to represent the whole thing as one big matrix if I wanted to, and then loop through that matrix. But I chose, instead of having this looping around all the data, I wanted to segment each data into this design structure. So I'm not saying my choice is right. It's the choice I'm familiar with because I'm a software developer by trade. When I come back and see this data, what I see is some structure, some model of the smaller things. Instead of treating it as one big monolith, instead of being all 101 columns, I want to break it down a little bit inside of there. So a few notes. I have some constants up here. Notice I have 2 tests per product, 5 products, and 10 concentrations that I'm testing. So these are those numbers that showed up here in the patterns, 2, 5, and 10. My start row is very pragmatic in that, let me open this as text because that'll open faster. So I'm skipping 1, 2, I'm skipping a couple of these initial rows because it automatically strips off the header, but it doesn't strip off a few of these other things inside of there. So I'm just telling it which row to start with, which is the interesting data. So that's what, I lost my code there. There it is. All right, so that's what these constants are up front. And then again, I'm just using read matrix to read everything at once. And then I'm focusing my concentration values. I'm stripping off essentially the first. So that's row number 1 and columns 2 through 11 gets me the concentration values of 3.75 all the way up to 2000. That's what this variable right here means. I should probably put more comments inside of here, but I don't think of commenting straight away because I've told you what it is right here, the concentration values. I'm not saying it's right, and particularly for this class, should be graded down if you don't put your comments in. But I also want to tell you that if you don't think to put comments in right away, it's probably the habit you developed. My habit is not to over comment everything. I try and create variable names that mean something meaningful, the concentration values. And once you see them in use, you probably would know what's going on. But I want to make sure I'm really explicit to tell you what's going on here. All right, so I'm starting at column 1 and for my logic here. Now, this is where we get into just simply reading this code. And so, as I mentioned, I have this nested loop structure. So for each product, for each test number, for each concentration, I'm going through and then I'm pulling in some number of samples. That's what I call that intermediate one. So I'm going to break this down here in a second, but I want you to look at this high-level structure. I just have 3 nested loops inside of here that is going through, as I said, for the 5 products, for the 2 tests, for the 10 concentrations. And I have all these inside of here as constants, so I can know which one I'm dealing with, inside of inside of each of the loops. I don't just have some number 5 to 10 because those are hard-coded. And those might change. If you got a new file, maybe they threw out one of the products. Like, yeah, this one's not working out. We're only gonna do 4 of the products. Or maybe they add more samples, or they do more concentrations. Who knows what different combinations could come up? So at least I've made it so I can just fix that all at the top of the file. All right, so I made the choice here. Initially, I was going to keep all the concentrations as one matrix. So I had every one of the concentrations across, every one of the values inside of there, and I changed my mind at some point. So you could have done it that way. You could have done it any number of ways. But notice in my code here now, does anybody notice anything about this assignment. So I'm creating this variable samples, and I'm adding a new row, a new vector inside of here every time I have a new concentration. So there'll be 10 of these when it's all said and done. There'll be 10 samples, which makes sense. That's what our problem says. But what's different about the syntax inside of this? If you want to answer, you can. I want everybody to think about it. So I'm not looking for the fastest answer. So if we consider this syntax here versus this syntax here, notice I'm using curly brackets instead of parentheses at this point. So you have not learned this feature in MATLAB. You can use it, but you don't have to. But this is what's called a cell instead of a vector or row. A cell allows you to not just have these vector or matrix of numbers, it allows you to have a vector matrix of anything you want to. So in this case, I'm going to the data, I'm going from the start row, which is the first data item I went to. I think I skipped the zeros. I don't remember. I went back and forth on that. So there's a column, a row of zeros inside of there. I don't remember if I kept the zeros or skipped the zeros inside of it. I think I went back and forth, and I had 4 at one point for my start row, but the point was my variable, it doesn't matter because I can move that around by just changing the hard coding up top. And so then I'm going from my beginning content. So in my data, I'm starting with my beginning column index, which is 1, but then I'm adding in the concentration that I'm looping over, which is 1 to the number of concentrations, and then I'm going to loop over, then I'm going to grab that specific vector that's coming out of that column that's coming out of that. So the first time I wrote my code, I actually just started with this. I wasn't worried about doing all 101. I was just worried about doing the first, the first test. So I start at 1, which is actually the time, but then I'm adding 1 to that, which is the concentration. And then I, 1, 2, so I go 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and I get the 10 concentrations. The next bit inside of there is I'm using this command from MATLAB called rm_missing. RM standing for remove. I don't know why they just don't spell out remove, but RM is a Unix thing for like remove directory. You can do it in Windows as well. But RM is a shortcut for remove. And so what this does is when I do the read matrix, everything that's not filled in with a number gets filled in with either a 0 or not a number. And this removes all the not a numbers. So if you want to actually know how many items are in your actual data item, this is required. I didn't check if rm_missing works on a matrix. That might be something you want to explore. So if you're trying to figure out how do I get rid of some of these things, this could be a way of helping you. And it might work on a matrix as well. My guess is it would. But I'm doing these one at a time, one concentration at a time for my own reasons and purposes. So that's what this line does, is it gets off the 10 concentrations, starting at whatever column index I'm working at, and working 1 through 10, the number of concentrations that's going on. So once that's all done, I take those 10 those 10 vectors, and I throw that into some number of trials based off the test number. And so there'll be 2 entries that get me that matrix that comes out. And then after that, I update my starting index to be that plus the number of concentrations inside of there. So I could have done number of concentrations here, and that actually, I debate. Looking at this, I can debate either way. I use concentrations, which is the index variable, and that actually wouldn't work in a lot of languages. I probably should use number of concentrations looking at this. But the point is, I grab 10 of them, and then I update my starting point from wherever I was to 10 later. And that actually covers all the rest of reading all the data. And so I take so I take the 10 concentrations I read, I take all those 10 and throw them into a sample. I get 2 samples, update to the next test, and then when I'm done with all the products, so I'll have 2 of these. When I'm done with it, with the product, I throw that into a list of all the products. So let me actually put a breakpoint here and just show you what this bit of code does by looking at the variable. Another reason, by the way, that I didn't create a I usually define function is that I can see all my data inside the workspace without having to use breakpoints all the time. But here, so all tests is my outer variable. So you can see all test is a 1x5 cell. So when I open my 1x5 cell, you can see I have the 5 products. If I wanted to, I could actually give these a text name inside of there as well. I'd have to hard code that or read it, figure out where to read it from the file. But I could attach the names as well because a cell doesn't require you to have all numbers inside of that. So then inside of these 5, you can see each of them have a 1x2 cell. So each of them have the 2 test trials, the trial and the duplicate. So if I open just one of these, you can see now I have 2 cells of 1x10, which is the 10 concentrations for each one of the trials. And if I open up one of these, you can see now I have 10 vectors of some number by 1 based off of the different concentrations. So logically speaking, if you look at the data this way, you can see that the slower concentrations get eaten up faster so that they're done quicker. They maximize out their curve, in this case, after 1400, 1800, 2000, all the way up to the longest is 7,484 seconds. So some of the trials just take a whole lot longer. But because of the hierarchy I have, I now have arranged this hierarchy appropriately. The nice thing about this is, since I have this data structure set up, I never have to, in all the rest of my code, have to remember what the indices mean. That's the biggest value of me setting it up this way. The logic I put into my code here, and let me back out of these. The logic I put into my code here around how do I navigate between individual products, individual tests, individual concentrations, I never have to worry about again, because I've now put that into the data structure in the model I want to. I'm not saying you should build your code this way. You could take this logic and have it be elsewhere in your code. It could be in a couple different user-defined functions. That would be sensible, since you probably never saw the cell. You haven't coded your logic that way. But I want you to see this alternative as well. I do not expect that you will all start now using cells. A few of you might choose to use cells. I don't expect that you should be screenshotting this and slapping it out there. Because remember, if you do it, somebody else might do it, and then they'll be saying, like, why does your code all look the same? Well, we took Tony's code, and that's why our code all looks the same. That's against the spirit of the academic honesty policy. Once you finish your coding classes and you need to go write code for a profession, find this code, steal this code, reuse this code, follow the attribution rules. If you create it for a product, you have to be aware of what the rules of that are. If there's a licensing issue around that, you have to be aware of that. So it's not, academic honesty doesn't go away once you hit industry. It just means your company could be sued over stealing code, which has happened before. I look at Google and Oracle right now are fighting over that with Java. But definitely for class, you can use something like this, but don't just grab my code or change the variables or something like that. All right. So any questions around this data structure? Does everybody see basically how I went from a whole bunch of columns to a nested data structure that describes it models the meaning of that data? All right, so from this point out, everything I have is just straight framework. There's nothing that's worth copying. There's nothing that's worth emulating in the rest of this. But it is worth showing you what's going on. So let me hit the continue button here and just let it pop up everything that's going to pop up. There it goes. So I've turned off a bunch of the, actually, I'll show you what I did as well. But I end up producing a chart that looks kind of like this. So kind of so what these charts are showing us for the 5 different products. I'm not saying this is the right type of chart. I just don't like having to close a bunch of figures, which is, by the way, that's where I have this close all statement. This closes all your figures, and I actually have that close all statement in the middle. I produce a bunch of figures, and then once I was done with them, instead of deleting that code or commenting that code out, I just did a close all. So I open up a bunch of figures and I close them all, which isn't super efficient, but it is. It was a cheap and easy way for me not to have to hit X a whole bunch of times. So this is that. Notice the concentration versus the velocity curves that I came up with. I calculated, and we'll talk about this in a second, my Vmax. And in order to be able to calculate my case of M, I wanted to be able to zoom in here and see, okay, so this case of M should be somewhere around 175-ish, where this one is going to be somewhere around 225-ish, and this one's going to, so I can see each one of these. So I calculate basically on each of these charts, I calculate my Vmax, and this is Vmax over 2, which I just plot a line, to do that, so I can give myself a visual representation. And then I had, for each of the 5 products, I have not done any data smoothing. That's the other thing I haven't done. To let you to continue to work on. But I calculated a bunch of Vmaxes and case of M's off of that. And I'll show you the crappy little algorithms I used for that. But we can see the number that came up for the case of M. I can go through and compare. I just guessed number 5 was around 175. Well, I have, my formula came up around 165, 161 to 165 for the 2 different tests. Again, I'm not saying these are the right formulas. They are intentionally crappy, but I want you to see the big picture of what I have going on. So I start from grabbing that data, and then I come up with those charts. So let me take out my close all real quick, and I can show you the intermediate charts inside of here. So I'll run it again. I don't remember if I turned the breakpoint off, but sorry, my run button is right underneath the Zoom header. I did not turn the breakpoint off. Let me do that. All right, so this will pop up with all my charts now. So there's the one you just saw, but then I, again, was lazy in that I just wanted to be able to chart this out. This is not a good presentation. I just wanted to be able to make some charts and be able to show you an example of what the charts look like. But if I zoom in here, you can see I've charted all the angles of each of the curves, all the velocity, the initial velocities of all of them. And I put all the concentrations on one. And then I have 5 of these figures. So for each test, I have 2 trials, and then each of the V0 that I was calculating out of that. So just show you the visual representations. Why do I have the visual representations? 2 reasons. Number 1, it gives me a gut feel for what my data is doing. Number 2, you're going to be asked to chart something like that at some point. So for my work, I just wanted to be able to see, I mean, simply, the first thing I did when I wrote this code, I wrote the data coming in, I wrote those loops, I said, good, I got all the data, let me go plot it. And then when I plotted the data, I realized I had a bug in my algorithm for reading the data in, and I was actually plotting the same data 5 times. All the curves matched exactly. I wouldn't have gotten that had I not looked at those curves and realized that was going on. All right, so now you can see, once again, I'm following the structure. For each product, I'm going to create another figure. For each of the test run, I'm going to create a subplot. And then for each concentration, I'm going to go off and do the logic. We'll come back to that in a second. And then the results of what I'm capturing here is I'm capturing a V0 for each concentration. I'm capturing all the V0s for each test run. and I'm capturing all the data for each of the tests. So I'm building a second structure essentially that comes in, which stores all the data as a result of what's going on. So I'll show you my crappy algorithm just so you have a sense of what's going on. I grab the current data off of the product, test, and concentration. So see how much my data structure pays off at this point? I want to know what current data I'm working on, product, test, and concentration. For some of you, in some of your M1s, you talked about averaging values across the 2 test runs. So here, if I know I have 2 test runs, I can do test run 1, test run 2, either hard code that or loop that however you want to, and calculate the average so you can get your current data could be the average across those 2. You'd have a little bit of extra algorithm that's going on in between those. Again, I'm not saying smoothing is the right way. Averaging the 2 is the right way. You might use the 2 of them as a balance. So you could average the data before it's coming in, or you could average the data after you've done the calculation, or something else. I don't know what the right answer is right now. I haven't worked the data that far. So I figure out what the so my Vmax, I'm taking a super lazy way of doing Vmax, and it's not even actually the best Vmax because sometimes the curve goes back down a little bit, but I'm grabbing the Vmax as being, where am I doing it? Oh yeah, so I'm actually doing the next loop. But my Vmax, I'm saying what is the last value in all the V naughts inside? Oh yeah, I'm sorry, I'm in the wrong curve. I apologize. I looking at the wrong value. All right, so I'm looking at V naught in this curve. I apologize. I jumped ahead of myself. So the length of the current data is just simply trying to get how many items I need to create for the time for each plot. And so I make a new time plot for each one, so I don't have, they have to be even X, Ys in order to make that time plot. So I plot everything as it stands, the current data versus its time, and then I am looking at the difference between, what did I say? Oh yeah, V naught range. So I chose 51 inside of there. So I'm not looking at the 0 and first. I'm not looking at the 0 and 100th. I chose 51. Is 51 sensible? I don't know. I mean, so 51 is trivial when there's 7,500 time points out there. 51 is kind of big when there's 1,400 time points out there. Maybe I should be doing some percentage of it. Maybe I should look at 1% of it or a 0.5% of it. Or maybe I should be only doing 5 or 6. I haven't done that analysis to see how that V naught changes across each of those. How do I know the 51 even makes sense? What if the 51 on that run happens to be anomalously high or not, excuse me, anomalously low? Sorry. Maybe I should be looking at the average of the values between 45 and 55, or something like that. So again, this is not necessarily the best way to do it, but I'm looking at the difference between 2 values and I'm doing a mx plus b slope approximation of that. And that's the number I'm saving. So then, as I said, my Vmax, I literally take the highest, whatever the last of the concentrations is. So is that the best one? I don't know, because I'm looking at them individually. Maybe the Vmax should be the average of the 2 tests I've run out or something like that. There's a lot of options. So once I figured out my V naughts, then I go through a loop once again for each product, for each test run. I'm going to plot all of the V naughts for those concentrations. Vmax being the biggest one. And then for my, yes. So what I did here to figure out my Km is I loop through all of the concentration values, looking for the first value that's Vmax over 2. And then I do a linear approximation between those 2 values. Now notice I'm cheating and using a break statement here. You're technically not supposed to use a break statement. I'm a programmer. I'm neither afraid of break statements nor do I think it's inappropriate in this logic. But if you look through this logic, what I'm doing is I'm searching this loop to find whichever the index is that's greater than the first one that's greater than Vmax over 2. And then I'm breaking out of that. And then I'm using that index to say, hey, give me the index and the index before it, and calculate for me the line between those two. And then I figure out what the intersection point of that specific V naught over 2 is and calculate my Km over there. So essentially I'm defining those 2 points around it, and then I'm figuring out the line equation between that, and I figure out exactly where Vmax over 2 is, and I calculate my Km off of that. Again, this is my unsmooth data. It's a way of solving the problem. It's not necessarily the way of solving the problem, but I think this one isn't bad compared to the other hacks I'm throwing out there. All right, so that is my cut, very rough at getting you to something that looks like M2. This is not M2. There's a lot of refinement that needs to happen here. As I said, I spent an hour, maybe an hour and a half coding and debugging this. For me to consider this close, I would probably spend at least another half an hour to an hour to wrap it up into something that would look like into the appropriate problem. Let me show you something to show you a little bit of the power. Here you go. I've been playing around with modeling, nonlinear modeling around the outbreak numbers, the daily percentages. And I don't want you to take any of this analysis as anything more than me playing with the numbers just to show what MATLAB can do. But I've created a bunch of subprograms here which will help me create logarithmic models, power models, exponential models of the data we have going on here. And then I have a little bit of some smoothing that's happening as far as the curve goes, not data analysis smoothing, and some analysis plotting going on. So let me show you what happens when I run this. This is the Indiana data. I've done it nationally as well, but this is a slightly simpler model. So let me pull over these figures in the order they present. So what I've done is, this is the number of cases in the state of Indiana over the last 30 days. So the analysis, you know this analysis, I put it on a log X chart, a log Y chart, and a log chart. So clearly, if it's going to be a linear model, the closest linear model once I've done it is probably this log Y chart, making it an exponential case. So this is a user-defined function I created, show analysis plots. You can see I create a figure with 4 subplots, 2 by 2, and that's what I'm showing here as a user-defined function. This is not super useful outside of me making the choice of which one of these models do I want to apply. So to show you how it works, oh yeah, this is a different set of data. Sorry. You jump through a couple of these. There you go. And so now, if I use the power model, we can see the linear model doesn't work really well for the power, and it's way below, the power curve is way below what the actual data is. The power model is a bad model of this so far. But if I go to the exponential model, the linear model looks good, and here's the exponential model. So the good news is that we have a nice model for this overall. The bad news is it's still an exponential model in the state of Indiana. The good news is it's not holding that exponential model all that well. So we have 4,944 cases in the 29th day. The exponential model says we should have 8,400 cases. So perhaps, and I'm not an expert, but perhaps maybe some of the social distancing is working in the state of Indiana. So we definitely have jumped up exponentially on an exponential model, but it's maybe not as bad as it could be. And so if we look at the model here, yes, so we are clearly not jumping by doubling the cases every day. And we're actually doing better even than this model out here. So again, the point of this is not to, trust the analysis of the experts on epidemiology and whatnot. But this is the type of thing we can do, and you can see the use of user-defined functions is really nice here, because when I want to do any of these models, all of the analysis that you typically have done, I can put into one subprogram. And so what I've done is a number of different analyses based off of days and whatnot. And so if we look at the US overall numbers, we actually started off an exponential model. I think we're actually starting to move into a logarithmic model. So it's in the more recent days. So that's a good sign that something might be working. But anyway, that is a little bit about the MATLAB that you should be diving into. I, again, don't expect you to follow this model. I don't expect you to change what you've worked on if you're happy with it, or even if it's just working for you. But this particularly, I wanted to show you a few of the MATLAB tricks. I wanted to show you where, some weak analysis looks plausible, and where maybe it won't look as good once you get further into the data. There's a lot of variability in the numbers that that I came up with that has to be accounted for. So you can see there's some big ranges, and there's some small ranges and some big ranges. So the Vmax, not all that different here, but there's a big difference in Km potentially on some of these, not on others of them. You see this one, the Km is probably somewhere around 253, where this one, it could be anywhere from 25 to 45. So that's why you do need to consider your data smoothing, and plotting these charts individually and not putting them all in one will help you see some of the differences as well. So anyway, let you ask any questions you have remaining, and then we can head off into your own teams.